Hi, in this session we will look at two important concepts regarding numbers, the LCM and the HCF. What do you mean by LCM? LCM stands for the least or the lowest common multiple and HCF stands for the highest common factor. Let us understand this with the help of a few examples. Consider the numbers 12 and 16. Can you tell me what is the LCM of 12 and 16? Let us look at the term LCM. LCM stands for lowest common multiple. So let us look at the multiples of 12. What are multiples of 12? Multiples of 12 are 12 into 1, 12 into 2, 12 into 3, etc. So multiples of 12 are 12, 24, 36, 48, 60, 72, 84, it goes on. There are infinite values. What about 16? 16 into 1 is 16, 16 into 2, 32, 16 into 3, 48, 64, 80, it goes on. Now when you go through this, you see that the first common multiple occurs at 48. So the lowest common multiple of 12 and 16 is 48. That is what we call the LCM of 12 and 16. Now let us come to the HCF. If you look at these numbers, and if I ask you to find the highest common factor, first of all, you should understand what a factor is. A factor of a number is another number which will divide this number into a whole number. For example, 12 divided by 2 will be 6. So 12 is divisible by 2. So 2 is a factor of 12. Similarly, 12 divided by 6 will give you 2. So 12 is divisible by 6. So 6 is also a factor of 12. Usually, factors occur in pairs. That is, 12 can be written as 12 multiplied by 1. So 12 and 1, both of them are factors of 12. 12 can also be written as 6 multiplied by 2. So 6 and 2 are also factors of 12. Another possibility is we can look at 12 as 4 multiplied by 3. So 4 and 3 are also factors of 12. Now if you go further down, then we will get 3 multiplied by 4, which is the same as 4 multiplied by 3. So the number 12 has 6 factors. What about 16? 16 can be written as 16 multiplied by 1. So 16 and 1 are factors. It can be rewritten as 8 multiplied by 2. It can be written as 4 multiplied by 4. So all these 16, 8, 4, 2 and 1 are factors of 16. Now let us see which is the highest common factor. 1 is a common factor, 2 is a common factor, 3 is not a common factor, 4 is a common factor, 6 is not a common factor, 8 is not a common factor, 12 is not a common factor, 16 is not a common factor. You can observe that the highest common factor among these will be 4. So 4 is the HCF of 12 and 16. A method that you can employ to find the HCF is like this. If you are asked to find the HCF of 12 and 16, we can factorize 12 and 16 like this. We look for a common factor. 2 is a common factor. So if I divide 12 by 2, I get 6. Here I get 8. There is again a common factor between 6 and 8. So I divide again with that common factor, which is 2. So I get 3 and 4. Now between 3 and 4 there is no common factor other than 1. So you cannot divide it further. Now we observe that this 2 and this 2 were common between 12 and 16. So the highest common factor will be 2 into 2, which is 4. Let me give you a couple of examples more. Let us look at 10 and 15. Let us find the LCM and HCF. LCM stands for lowest common multiple. When you look at this, by observation, you can say that the multiples of 10 are 10, 20, 30, 40, etc. Multiples of 15 are 15, 30, 45, etc. You find that there is a common factor, common thing here. 30 is common for 10 and 15. So the lowest common multiple will be 30. If you're looking for the highest common factor, then you go like this. You first try with 2. 2 is a factor of 10, but it is not a factor of 15, so you can't divide by 2 here. 3 is a factor of 15, but not a factor of 10, so you can't divide by 3. Next, you go for 5. We are looking for prime factors here. What are prime factors? Prime factors are factors which are prime numbers. So the next thing that comes into our mind is 5. 5 is a factor for 10 and 15. So we divide both these numbers with 5 and then we write what is remaining, 2 and 3 here. There is no common factor other than 1 between 2 and 3, so we stop. We see that 5 is the only common factor between 10 and 15. So HCF of 10 and 15 will be 5. Now let us look at a case where we have 3 numbers. Let us consider 6, 8 and 9. Let us first find the LCM of 6, 8 and 9. What is the LCM of 6 and 8? If you go through the multiples of 6, you can say 6 into 2, 12, 6 into 3, 18, 6 into 4, 24, and so on. 8, it will be 8, 16, 24, 32, etc. For 9, it will be 9, 18, 27, 36, etc. So when you look at these two, you see that the common number that comes in the multiple, the lowest common multiple between 6 and 8 will be 24. What about 8 and 9? You see that it is 8 into 9 because there is no common factor between these. So the LCM will be the product of 8 and 9. So it will be 72. What about 6 and 9? 6 and 9, you go through the multiples of 9, you see that 18, the second multiple of 9 will be the third multiple of 6. So 18 is the LCM between these two. But what we want is not the LCM between two of them. What we want is the LCM between 3 of them. Okay. So one method is you look at, using trial and error, you look at the multiples of the biggest number. Let us say 9. Look at the multiples of 9. Which are the multiples of 9? 9, 18, 27, 36, 45, 54, 63, 72, 81, 90, 99. It goes on. Is there a multiple of 8 in this? Yes. Which is a multiple of 8? You find that 72 is a multiple of 8. 9 into 8 is 72. Now, is there a multiple of 6 in this? Yes. 18 is a multiple of 6. 36 is a multiple of 6. 54 is a multiple of 6. But none of these will be a multiple of 8 over there. So, the common multiple of 6, 8 and 9, we find that the lowest common multiple of 6, 8 and 9 will be 72. This method is a trial and error method. Now if you go by another method that you would have learned in your school days, what we do is, we look at the factors of these numbers. The numbers are 6, 8 and 9. Similar to the method that we employed for finding the HCF, we go for the factorization. But here we don't go for the common factor, we go for any factor. Let's see. 6 is divisible by 2, so is 8. So we divide by 2. But 9 is not divisible by 2, so we leave 9 as such. And we divide 6 by 2, we get 3. 8 by 2, we get 4. 9, I am keeping it as it is. Next thing that I do is, I look for 2 again, because 4 is divisible by 2. I am dividing by the number 2 as much as possible. And I stop only if there is no possibility of dividing by 2 anymore. So this is 3, 2, 9. There is one more 2 here. So I again divide by 2. So 3, 1, 9. Okay. Now I go for the next number. I go for 3. There is one 3 here. So I divide again. I put it like this. Now I look at these numbers here. My LCM will be 2 into 2 into 2 into 3 into 3. That is 2 multiplied by 2 gives me 4, multiplied by 2 gives me 8, multiplied by 3 gives me 24, multiplied by 3 gives me 72. That is the LCM of these three numbers, 6, 8 and 9. Now what about the HCF? What about the HCF of 6, 8 and 9? When you look at these numbers, you see that there is a common factor between 6 and 8, which we can take it as 2. There is a common factor between 6 and 9, which we can take it as 3. But there is no common factor between 8 and 9 other than 1. So there is no common factor between these three numbers, and so the HCF of these three numbers will be 1. 1 is a common factor for any integer. 1 is a factor for any integer. So 1 is a factor of 6, 1 is a factor of 8, 1 is a factor of 9. And since there is no other factor which is common between these, the highest common factor of 6, 8 and 9 would be 1. Now let us see where you apply these in common problems that come in aptitude test papers. In aptitude test papers, you will apply these in some word problems that come your way. Let me give you an example. Let us say there is a factory in which there are two machines. Let me name the machines machine A and machine B. This machine A makes a beep sound every 5 minutes. This machine B makes a beep sound every 6 minutes. They just happen to beep together at this moment. When will they beep next together? When will they beep together for the next time? After how long will they beep together next time? So let us look at this machine A. It has just beeped. After 5 minutes, it will beep again. After another 5 minutes, that is after 10 minutes, it will beep for the second time. Then it will beep at 15 minutes. Then 20, 25, 30, 35 and so on. It goes on. What about this machine? It will beep on the 6th minute, 12th minute, 18th minute, 24th minute. Please look at this. These are all multiples of 6. 30th minute, 36th minute and so on. Is there anything common between these two multiples? Yes. 30 is common multiple of 5 and 6, and 30 is the lowest common multiple of 5 and 6. So after 30 minutes, these two machines will beep together again. So they will keep beeping together after 30 minutes, again after 30 minutes, again after 30 minutes and so on. The first time that happens will happen at the LCM of 5 and 6. Okay. What if there was a third machine which beeps every 8 minutes? So I have a machine which beeps every 5 minutes, another machine which beeps every 6 minutes. What about a third machine which beeps every 8 minutes? All three of them happen to beep together at this moment. After how long will these three beep together again? That's the question. So what we have to do is, we have to find the LCM of these three numbers. What is the LCM of 5, 6 and 8? Let us go by the factorization method of finding the LCM. We can divide by 2. I can again divide by 2. Then I go with 3. Then I go with 5. So LCM will be 2 multiplied by 2 multiplied by 2 multiplied by 3 multiplied by 5. So what will that value be? It will be 120. 2 multiplied by 5 will be 10, multiplied by 2, 20, but into 2, 40, multiplied by 3, 120. So the next time they will be together will be after 120 minutes, that is after 2 hours. Okay. Now that we have seen problems where we apply the concept of LCM, let us look at a problem where we apply the concept of HCF. Let us say you have a rectangular room which has dimensions 18 feet and 24 feet. Length is 24 feet and breadth is 18 feet. Now let's say you are trying to tile this floor of this, tile the floor of this rectangular room whose floor dimensions are given like this, 18 feet and 24 feet. Now the requirement is you have to tile it using identical square tiles. All the tiles that you use should be square, they should be identical. You should not break the tiles, it should be correct fit. And there is one more condition, you should use the biggest possible tile that will fit the requirement. So you have a room whose dimensions are 18 feet and 24 feet. You are supposed to tile the floor of this room using square tiles, that is length and breadth of the tile should be same, and these tiles that I use should be identical in nature. I cannot have a small square and a big square, that is not allowed. All the tiles that I use should be identical. Then the requirement is the tile should be as big as possible such that I need not break the tile for the tiling purpose. So if you want to fit the tiles here properly without breaking, what should happen is this side of the square tile should be a factor of 18. Then only it will fit correctly here. Similarly, the side should also be a factor of 24. Then only it will fit correctly here. So we are looking for a value over here, let us say x, such that it is a factor of 18 and it is a factor of 24. Okay. Common factors of 18 and 24, I can say 1 is a common factor, but is it the highest common factor? No, 2 is bigger than that, 2 is a factor of 18 and 24. So we are looking for the highest common factor of 18 and 24. Let us see, 18, 24. Let us look at the common factors. 2 is a common factor. I can't divide by 2 anymore because 2 is no more common between 9 and 12. I go for 3. Now there is no common factor between 3 and 4 other than 1, so I stop. So 2 is a factor of 18 and 24, 3 is a factor of 18 and 24. The highest common factor of 18 and 24 will be the product of 2 and 3. 2 multiplied by 3 gives me 6. Okay. So I will use a square tile whose dimensions are 6 feet and 6 feet. Okay. So this is an application of HCF. How many such tiles will be required? I will need 3 tiles in this direction because 18 divided by 6 will be 3. So I put 3 tiles in this direction. What about in this direction? 24 divided by 6 will give me 4. So essentially I will use 4 such tiles in this direction. So 3 tiles multiplied by 4, I will be using 12 tiles of dimension 6 feet by 6 feet for tiling this floor. Okay, I hope you understood the concept of LCM and HCF very much. Thank you.